All right, so welcome everybody to Reasonable Faith in Norwich. We're continuing our conversation on a variety of different topics. And so lately we've been focusing on the cosmological arguments for the existence of God. And the first one that we talked about was the Leibnizian cosmological argument, which dealt with heavy science or heavy philosophical stuff. We're not going to be going into that again, so don't worry about it. But that one just talks about things that don't have to exist versus things that do have to exist. And as Christians, we believe that God has to exist. Like God cannot fail to exist. And this argument explores the reasons for why that is. And so now we've moved on, and we've been talking for the past few months about the Kalam Cosmological Argument. And the Kalam Cosmological Argument is more focused on whether or not the universe began to exist. All right, so, and it's more focused on the causal principle of things that begin to exist as a cause for its existence. So, right now, as I do all the time, we're going to be going to the whiteboard and just seeing if we can talk about or put the Kalam up here from memory. So does anybody remember the first premise of the Kalam cosmological argument?
You mean like, is it whatever begins to exist has a cause?
Correct.
Oh, okay.
Yep, that's right.
So that's Kalam.
Yep, that's the Kalam. And all right, so the Kalam dealing with whatever begins to exist has a cause. And in earlier sessions, we went into great detail in defending this this premise against people that want to dismiss it or people who want to say that it's not reasonable. And but we walked away saying that this premise is like rock solid. Like it's something that we as humans kind of just intuitively accept. When you see something that begins to exist, you look for causes, pretty much for anything that we see around us. If we're curious about that item, then we want to see how it was fashioned, how it was made, why it came to be. That's the whole point. That's one of the major points of science, is to discover causes and then to use those causes for our benefit, okay, to produce effects that we want. And then the second premise that we're going to be focused more on today is, what was it?
The universe began to exist.
Yep, the universe began to exist. Okay, and we talked a little bit about this in the past few sessions when we were talking about two philosophical arguments for the existence of God that we're not going to be going into tonight. But they're talking about the differences between potential infinites and actual infinites. Like the potential infinite would be like an everlasting future, kind of like how we envision usually spending time with God in heaven. It goes on forever and it doesn't stop. Where actual infinites is like a completed set. And like Aleph Null is an example of a number that whose cardinality is equal to all of the natural numbers. But we're not going to go into that. We're just going to, tonight, we're going to be starting to talk about scientific evidences for the universe actually beginning to exist. Okay, so we'll talk briefly about what we mean by universe here, and we'll talk about like some recent discoveries that were made. And I'm not going to be going into too crazy detail about them. Okay? And then the third premise or the conclusion.
Therefore,
Expansion of the universe?
Nope, that's going to be one of the scientific evidences.
Oh, okay.
therefore the universe has a cause
Yep,
for its existence.
correct. Therefore, I can't remember, right now I can't remember if therefore has an E at the end. I'm pretty sure it does.
Therefore,
Yeah. Therefore, the universe has a cause for its existence. Okay. So whatever begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause for its existence. That is the Kalam, and that's all there is to it. When we talk about this being an argument for the existence of God, please remember that we're talking about it here in the third premise. So God is the cause for the universe coming into existence. And we as Christians have theological grounds for believing that. It's written in the Bible. Can anybody tell me where?
Genesis.
Yep, Genesis, you know. The very first verse in the very first chapter in the very first book of the Bible, in the beginning God created the heavens and the earth. So this idea that the universe began to exist isn't surprising to Christians, okay? It would be surprising to certain other philosophies or beliefs in which they would think that the universe is eternal. For example, like there's sects of Hinduism that believe that the universe, like the physical world, is like eternal. And also there's a lot of ideas with naturalism. There's a lot of versions of naturalism, which is a philosophical worldview dealing with, it's like a godless kind of philosophical idea of how the world operates, in which the universe is like past eternal or it has always existed. Okay? But for us, so a lot of scientists in the early 20th century had this notion that the universe was this eternal static entity. Okay? And this is what Dr. Craig starts to talk about in On Guard, that the idea that the universe was not static came as a surprise. Okay? And there were some scientific evidences that brought about that that change of opinion. And I guess, well, you guys haven't read the book. Just a second, let me grab the eraser. So we'll just talk about those, you know. So we're talking about the second premise of the Kalam. And right now, we already talked about the philosophical arguments. We're moving on to scientific arguments, or evidences, okay? So one thing that I need to stress in this argument is that cosmology is still very much in flux as far as like the field of science. There's always new scientific discoveries being made, and there's always new theories being produced. Like this question of the beginning of the universe is a very hot issue in that scientific community. When scientists deal with models for the universe beginning to exist, they're not interested in saying that God is the cause for the universe beginning to exist. They want to develop naturalistic models. They want to use just the laws of nature, and by using the laws of nature, develop an explanation for why we see the universe as it is, and for why we see the early stages of the universe. The interesting thing about the universe is that when you look up into the night sky, are you looking at the universe as it is now? Correct. So what are you looking at when you look up into the night sky?
Way past.
Yeah, the way past. You're looking at the universe as it was. Yep. So when you look at the universe as it was, we see some pretty interesting things. When you look out from the Earth as far back as you can, we see what is called the cosmic background radiation, and we don't really see it. We more like detect it. Okay, and so have you guys ever heard of the cosmic background radiation? So this cosmic background radiation is it's the energy of the universe as it was in its primordial state, or at least that's what people believe, that it's the primordial state of the universe, in which the dominant energy of that time was hydrogen, helium, and photons. Okay, so there's a lot of protons and a lot of neutrons, but there weren't a lot of heavy elements. Okay, so we can detect that energy. We have, instruments that are capable of detecting that kind of energy. Okay, when we talk about the universe, when you look out into it, out into the universe, and you see that the cosmic background radiation is that there's an earlier than point in which there aren't any like stars forming or anything like that, and then stars form later on. This marks off a process of what appears to be a beginning stage. Does that make sense?
You can actually see that just by
We,
looking.
we don't see it, but we detect that energy.
Wow.
Yeah. So when we look out into the night sky, what we see are galaxies and stars, and it's very far away, so it's hard to make out a lot of the stuff. But the astronomers and the physicists that do these investigations have tools that allow them to be able to craft a model of how the universe actually operates based off of certain energies, like the light energies that are given off, or the gamma rays or photons, provide us with the signatures that we can use in order to create a model of how the universe works. All right, and that's where the Hubble telescope comes in. When we launched you've heard the Hubble telescope, obviously. Okay, good. So what the interesting thing that they detected was that the light coming from the galaxies had a red shift associated with it. The light coming off was tinted redder than we would have expected. And it wasn't just like some of the galaxies or some of the stars had a red tint, but all of them, no matter where we looked, had a red tint to them. So what would be the significance of this red tint? Okay. So what is light typically? It's an electromagnetic wave. Okay. So this is a let's just call it a photon, and this is this drawing is supposed to symbolize an electromagnetic wave, and this is very similar to like a sound wave. Okay, So when an object is producing a sound, it produces waves of a stable frequency. But if the object is moving, what happens to the sound it produces? Has anyone been to NASCAR or are familiar with the noise?
Doesn't it compress?
It does. Yes, the motion actually compresses the wave, the sound wave. So when like if you go to NASCAR, what is the sound of the? Exactly. So the cars actually, the sound given off by the cars are actually at a lower pitch than what you hear as they're approaching you. So you get this high pitched sound, and then you get a lower pitch. So the sound waves are compressed early on, and then they become normal, just like here. The closer you get to, well, when you get to this part right here, if you're standing in this booth and you're looking at this car moving, and then the waves behind it are spread out because of the motion. So this is a lower pitch, and this is a higher pitch. And you can get the same effect from anything that's moving really fast. Or you can get the same effect by watching waves produced on water when people are swimming, or fish are swimming, or ducks when they're on the surface, They, when they're on the surface and they're paddling and everything, they're producing little water ripples. And when they move in a direction, what happens to the water ripples? They compress up onto the duck or the boat, okay? And then they get shorter and shorter as the duck or the boat is moving. And if this is a little interesting thing that doesn't have to deal with what I'm about to say about the universe light, but as it gets faster, you know what happens to the waves, right? The motion becomes faster than the ripples can be produced, and then you get those waves, right, from the boat, and you get the waves splashing out, and you don't get the ripples in front of it anymore. That's similar to how when a plane breaks the sound barrier. When a plane is going so fast that the sound that it produces can't keep up with that actual motion of the plane, it breaks the sound barrier. And it's like a sonic boom. But anyway, when we're talking about universes and everything, when the universe has motion and it's moving in a particular direction, the light given off is going to actually get compressed. And the light, and in whatever way that it's moving away from, the waves are going to become elongated. And on the light spectrum, the light with the higher frequency tends towards blues. And the light of the lower frequency tend towards reds. So what we've noted is that all the universes seem to be heading away from where we're at. And as a matter of fact, that they're not just heading away from us, but they're heading away from each other as well.
Expanding.
Yeah, this is giving evidence of the universe's expansion. Okay, so if it's the case that all the universes, all these dots represent universes, are heading away as time progresses, if you reverse time, what direction are all the universes going?
Going.
Towards each other, exactly. And if you keep going back, let me erase this. And if you keep going backwards in time, with all the universes heading towards one place, what do you get? So you get where all the matter and energy is heading towards a single point. And this point is called a singularity. And usually a singularity is, when they talk about singularity, it's defined as like a point where the density and the heat are infinite. Okay? So when we observe the universe is constantly becoming less dense and colder. But in the beginning, the universe was super dense and super hot. Okay? So, and then when you squeeze something down, and you hit the infinite number, you know, is there anything further back than that? The answer for that would probably, for most people, be no. Okay, so that's where a lot of people see this and they're like, man, that screams out that the universe had a beginning to its existence. You know, if all the galaxies, if you go back in time, are compressing and coming together in one, it wouldn't really be one place, because this is the whole universe. This is all space as well. But they're all coming together at one point, then they're going to be, then that cries out for a beginning. Any questions on that?
Would that be considered the Big Bang when it released?
Yeah. Yep, that's what this is dealing with the standard model. Yep, so that's the Big Bang. That's what we're going to be talking about with the beginning of the universe. And I know that a lot of Christians have issue with the Big Bang. And
I've heard issues.
yeah,
I'm not sure what, you know.
I hear you. Yeah, and I too have issues with the Big Bang. I don't really know what to believe. I kind of, I look at the evidence and what's happening in cosmology, and I kind of just watch and observe. But the standard model has lasted for a very long time, and a lot of it has to do with outdated physics, but it's still really good and it's hard to knock down. And what I'm saying here is that when doing this investigation, just bear in mind that science is all changing. So it could be the case that this scientific evidence is no longer applicable, and that doesn't mean that the universe didn't begin to exist. Okay, these things are just the point of scientific evidences are to support premises of philosophical arguments. And these philosophical arguments have premises that lead to conclusions that have theological significance. So that's just what we're establishing here. We are just supporting the second premise of the Kalam with this. So the data that we do see out there tends to support that the universe began to exist. All right, and that's not the only evidences too. So when we talk about the universe as compressing down and becoming down to one point and becoming hotter and denser, this deals with a law of one of Isaac Newton's laws. It's a second law of thermodynamics. When we observe how energy behaves in the physical world, do we see that when you put air into a balloon, what shape does the balloon make?
Round.
Yep, it expands, it becomes round, Exactly. Yeah, roundish. It depends on the tensile strength of
Yeah, right.
yeah, exactly. So, but like a soap bubble.
Right.
Why is the soap bubble round? The soap bubble is round because it's the most efficient shape. And why is it the most efficient shape is because of the second law of thermodynamics. So, which states that energy in a space is going to become evenly distributed throughout the space. It's not going to collect in any particular part. The energy is going to seek to achieve the lowest, exactly the lowest energy state it can. All right? And so that's why soap bubble is round, because all the energy is being pushed out equally and distributed evenly across the internal surface of the bubble. Okay? So that's why soap bubble is round. It's the most efficient shape. It's based off of the second law of thermodynamics, which we observe in the physical universe. And what we observe here is that if the universe started out hot and dense, and an infinite amount of time has passed, if the end state of the universe, we were talking about becoming cold and dark and less dense, if an infinite amount of time had elapsed, then we should be seeing right now, well, if there could be conscious observers, a universe that is infinitely, its density spread out infinitely thin, and it'd be cold to absolute zero, and there would be no pockets of isolated energy. That's what we should see, because the universe is constantly expanding outward. And also, this is also dependent on whether or not the universe is a closed system, which most people will want to say that it is a closed system. And by closed, I just mean like there's nothing going into it.
Okay.
So that's what the laws are based on.
But it's still red at the end because it's still growing. I mean, it's still expanding, but it's still red. It hasn't turned black, so it's still, I'm not saying it right, but.
Yeah, if there were observable
Right.
gamma rays, then it would be red because, but in this situation, there wouldn't, if an infinite amount of time has passed, then the energy level would be undetectable.
Level should be there.
Right, it wouldn't be
It should
detectable.
Be dissipated completely.
Yep, if an infinite amount of time has passed, if the universe is past eternal.
Right.
So when we see these evidences that seem to indicate that the universe began to exist, like the cosmic background radiation, the redshift of the galaxies, and the second law of thermodynamics, if you were to believe, if you wanted to avoid the possibility of the universe beginning to exist, and one thing that I'm going to emphasize right now, do you remember what we said earlier when we talked about the word universe? What did we mean by that word, the word universe? Anybody remember? So when we use the word universe in this argument, we mean all of space-time, matter, and energy. So this argument is assuming that the universe means all space-time, matter, and energy. So this would exclude theories such as like the multiverse. Okay, so so a lot of non-Christians and a lot of Christians too would say that what reason do we have to believe that the universe comprises all of space-time, matter, and energy? You know, but before we get into that, we're gonna kind of look at some basic models that talk about how the universe could be past eternal, or that it didn't have a beginning. So this is a standard model that I'm going to draw right now, and we're just going to compare different models to it. All right, so I'm actually going to erase this premise because I'm pretty sure we all know what we're talking about, the universe beginning to exist. All right, standard model. And there's also a little picture yep, exactly right there. So on the On Guard book, can you say what page number that is there, John?
90.
Yep, all right, so page 90. On page 90, we see that the standard model is depicted as like a cone. And when we look at this is time, and this is space. Okay, and as time progresses, this way, as it progresses, you see space expanding. Okay, does the graph make sense? So as time progresses, the universe gets bigger. Right here at this point, this is the beginning. Okay, so some other models that have been offered in order to avoid the eternality or the finitude of the past have been to talk about a cyclical kind of expansion and collapsing of the universe. So in this model that I'm going to draw here, this is going to be time, and this is going to be space. And this is an eternal theory of the universe, and so just because I'm stopping here doesn't mean it's a beginning. But basically, it looks like this.
It just keeps going.
And due to my human finitude, this wave is inconsistent, but it's supposed to be perfectly consistent, and this is only half of the wave. So please bear with me as I try to do this. And it just keeps going, and it's just kept coming. All right, so what happens here? What's happening here? So what this is basically saying is that the universe is expanding and contracting, and then it comes together, and then pow, it bounces back out, and then it comes back in. So what's causing it to come back in? Any ideas? Exactly, yes, gravity. So the idea would be that gravity is strong enough to pull everything back in. So everything bounces outwards, but gravity, doing what gravity does, it pulls everything back in, and then it, once everything collapses in on itself, it bounces back out.
Now, is that where black holes come in?
Black holes are very interesting. So that's possibly one way that a black hole is formed, is like through supernovae. Yeah. And what happens in a black hole, and this is kind of like the idea of how the universe could be past eternal. But when a star collapses, so like what causes the collapsing?
Well, gravity
Yep.
is pulling it towards the center.
Yes. Yep. So the gravity, the mass of the star has sufficient
collapses on
gravity.
itself.
Yeah. So a star is always in a perpetual state of collapsing on itself. So a star's gravity is always pulling the hydrogen and the other lighter elements into its center. Constantly pulling all that stuff in, and it's a really intense gravity. And what's preventing the star from collapsing on itself right now? What's preventing the sun from collapsing in on itself?
I never figured that one.
So,
Sorry.
that's all right. That's all right. It's what causes the sun to burn?
Well, hydrogen is burning, and it's all being pulled together because of gravity and weight. But that's the part I've never heard. Why is it still not
What kind of energy is the sun producing?
light?
It is producing light, that's for sure. How is that light produced? So at Millstone, we split atoms and produce energy, all right? And if you split an atom, and a really heavy atom, and produce energy, what happens if you fuse them? If you split this atom and it gets all wobbly, and then it splits, it produces a bunch of neutrons and a bunch of photons.
They're gonna go look for. They're gonna want to go back to their natural state.
What's interesting is that when you split atoms at a certain point, you're gaining energy. And so what I'm going to draw for you is a very basic energy distribution curve that's based off of the atomic weight of atoms. So right now we're going to be doing atomic weight, and this is very basic, so don't worry. And this is energy. Okay, so for Millstone, we have really heavy atoms. We use uranium, okay? Or most nuclear power plants.
238.
Right. And when you split the uranium atom, it usually becomes like xenon or what was the other one? Rubidium? I think that's a fission product daughter. I've been out of the field for a while.
Tritium.
No, not
No,
tritium.
No. It would be- no.
But this energy difference right here, because these are lighter elements, this is where like hydrogen and helium are. This energy difference right here is what Millstone utilizes in order to produce electricity.
Right.
Okay, but if you try to split like a carbon atom, it goes from this energy level to here. So if this is a positive gain, this is an actual negative gain, right? So what you're doing is losing energy. You need to put energy into it in order for that to happen.
It takes more energy to split it than you're getting out of it.
Exactly, yes. So in this one, it takes less energy to split it than you get out of it, the other way around. But on a star, you're not using fission, you're using fusion. Exactly, so that's the energy that it's producing. Okay. So when you take a hydrogen atom and you fuse it to produce a helium atom, you get this much of an increase. And you get way more energy out of fusion than you do with fission.
Right.
Yep, so that's the energy that's constantly throwing stuff out of the center of the star. So why the sun doesn't collapse on itself is because fusion is producing energy to throw material and matter out of the core.
You have just answered a question I've had for 40 years.
I'm here to support it.
I,
So that's how stars work.
that's
How-
how stars work. Finally, I
Yep. So
know. My life had meaning.
I thought I had meaning before. But so fusion is throwing that out, right? So but the where was I at? But when you start using up all the hydrogen and helium and all the lighter elements, you start having because the gravity is still pulling everything in and crushing it together, it starts to form heavier elements. The sun is constantly making heavier and heavier elements until it gets to iron. Iron is at the top.
Really?
Yeah. Once the star starts producing iron, it's going to die very soon,
Okay.
very rapidly, because in order to fuse iron, you need to put more energy into it than you get out of it.
Yeah.
Iron is star killer,
Okay.
okay? So
Interesting.
but since the sun is the same mass, but it's no longer producing the fusion, the energy required to throw the material out, what happens?
Starts collapsing.
Exactly. The gravity starts winning. So, and this is all very basic. I'm not like going into any strong. So if the sun's mass is good enough to have the gravity force strong enough to have everything rapidly collapse in, it will suck everything in, and then what will happen is that it will like blast past itself basically and explode outward. And any of the heavier elements that are collapsed inward it could become a black hole. There's a lot of theories about what a black hole is. I tend to think that a black hole is just a supermassive object. There's some people that think that like a black hole is like an actual hole in the space-time reality, and
But gravity can't escape black holes.
you're thinking of light. So light can't.
Cannot escape black holes.
Excuse me.
Right. Right. You're right.
Yep. So light,
Gravity.
yeah. So light can't escape black holes, but black holes are basically gravity run wild.
Right.
Okay. So
So inside of the black hole, gravity is stronger?
yep. It's stronger than anything. So if you're thinking of like space time, so this is going to be a very, again, don't judge me, but this is like, if we're talking about space time, and what gravity, a theory about what gravity is it's just a curvature of space time. And like if you think of a trampoline, you know, when something heavy is in the center, like myself, what happens?
Not heavy.
I am. What happens when a tiny 3-year-old girl, so cute, possibly named Sala, is running around the trampoline with a heavy guy in the middle? She wants to fall into the center, especially when she trips, which I may or may not cause her to do. So that's what heavy objects do to space-time. It causes it to curve towards, and this, I'm trying to do a 3-dimensional.
Right.
So with a super heavy object, usually it's just a divot. And space-time doesn't rip like a trampoline mat.
Right.
Maybe it does. Who knows? But what you see here is just the curvature of space-time being pulled towards this black hole right here. And that dip, this I'm going to do it straight on now. This, where it actually bends right here, that's called the event horizon. And so what this has to do with the beginning, with this model is that it could be the case that gravity, similar to how a star operates, pulls everything inward, and then the energy produced by the rapidly collapsing universe is enough to rebound everything back out. So like a super crazy massive black hole, but somehow a black hole isn't formed. And also, so it wouldn't be like, the space-time wouldn't be like kind of like bouncing back out. It'd be more like shooting past each other and spreading out in the other directions and things like that. But there's a couple issues with this model, all right? And one of them is the idea of black holes, forming black holes, and how that information gets locked into those super dense entities. And then if you're constantly forming new black holes in each one of these, then you get less and less energy over time. Right. So what you would see is that the first universe, or I mean, like there is no first on this model, but you would see a progressively smaller wave as you
progressively teeters out.
Exactly. And that would just provide evidence for a beginning of the universe again.
Yeah, right.
And that's a problem. That's the whole point of this, is to avoid that.
Right.
All right. So, and also this model needs to be extraordinarily fine-tuned, but I mean, like, that's no different than the standard model. The standard model needs to be super fine-tuned as well, so there's not that big of an issue there. But that's why this model isn't really adhered to. Does anybody have any questions on that? So that's how stars work. And
So I guess black holes never closes.
right, yeah,
They
as-
just move on as is.
supposedly. There's also the idea that black holes give off a radiation called Hawking radiation, and over the course of an infinitely many number of years, the energy that radiation would eventually dissipate the black hole into a nothingness, which is kind of weird because, like, if that energy, radiation, light is radiation. So it's like, how does that, and I don't doubt it, like, because these guys are a lot smarter than me and I believe it, but I don't really understand how, and I haven't taken any advanced courses on this or anything like that, so I don't really understand how the Hawking radiation escapes the black hole if light can't escape.
Yeah, true.
Yeah, so that to me is confusing, but I have no reason to doubt Stephen Hawking. All right, so so that is one view of how this universe could have no beginning. All right, and and we've seen why we reject it is because the energy would constantly probably be forming black holes and be lost to those black holes and become smaller and smaller and smaller, and then the whole point of another problem with that one is that it doesn't seem to be the case that gravity is strong enough to pull everything back in. So when we see the expansion of the universe, the expansion is actually speeding up. And it doesn't look like there's enough mass in the universe in order to pull everything back in based off of our calculations. So that's another reason why that reciprocating model doesn't seem to work. Yeah.
Because you keep losing stuff along the way, so.
Right.
Yeah.
It's getting it, and the beginning, or the beginning of that rebounding out has heavier heavier objects in it that have stronger gravity. So the expanding out would be smaller each time because of the heavier objects there. That's keeping the universe smaller and smaller and smaller until it's just like it probably just all eventually collapses into a giant black hole.
Okay.
So even on that model, we have evidence that the universe began to exist. Okay? Let's see here. What else should we talk about? We don't have much left. There's ideas that when we're moving beyond the universe, there's a lot of ideas dealing with like the multiverse, or perhaps that this universe is a daughter universe to some bigger universe out there. So they would say, the second premise of the Kalam is true. You know, the universe does have a beginning. But God didn't cause it. So that's where a lot of atheists would go. Most of the atheists that I interact with will say that the universe
Just happened?
well, basically, yeah. A lot of them will just say that the universe is a brute fact, that it just exists. This is what we talked about with the Leibnizian cosmological argument, that the universe exists inexplicably, that it just is, and there's no explanation for it. And we talked about why, at least us Christians, we're not satisfied with that answer.
It's easier to believe there's a creator than trying to find an answer to something that you can't explain. God is bigger.
But it's on our side than the atheist is saying, or the non-believers. They're saying, no. They're seeing it on the flip side.
Yeah. So they would say that the universe, this universe that we observe, this is just the observable universe. That physical reality is beyond this. Like, here's our universe. This is what's observable to us, but there's more beyond it.
See, that's how I would think so. Because if God, no, I'm saying it in a question form. If God is so big and so everything that is way beyond my mind span, wouldn't he go way beyond and, you know?
Yeah.
But you know, that's what I would think.
I fully agree with you there. Personally, the way that I think that reality is constituted would be like, imagine that God, and I've showed you guys little pictures before, but imagine God is this whiteboard. And the only reason why I'm using the whiteboard is because I don't have anything bigger. But basically, God is represented by the whiteboard. He is the ground of reality, you know. He is the most fundamental. John Hick would call God the real. God is reality. Okay? And then with God has created things that cannot exist without his existence. And this would be like the spiritual world. This would be like the heavens. this would be like heaven, God's throne room. You know, the Bible says that God even extends beyond this. You know, so there's the earth, and then there's the first heavens, which is like the firmament, the atmosphere, the sky, and then the second heavens, which is outer space. And then Paul was taken up to the third heavens, and this would be the third heavens. And then within the spiritual world, because the Bible teaches that the physical world is like, the physical world that we see around us is like a metaphor for spiritual truths. Okay? So the physical world resides within the spiritual world as a part of it, a smaller part of it. And then within that is the observable universe. And then within that is like our galaxy, and then our solar system, and then Earth, and then the United States, and then Connecticut, which is already a tiny state, you know? So this is kind of like how the Christian believes how the world is constituted. And the physical world can't exist apart from the spiritual world, and the spiritual world can't exist apart from God. And none of this at all can exist apart from God. There is no, so like when you, a lot of times when people talk about possible worlds, they like to think of like possibly the physical world is all there is, and then God doesn't exist. From our perspective, that makes literally no sense, because the physical world can't persist for one moment without God.
Right. I've been seeing a lot of places where they have multiple universes, you know, it's like, I can't explain it, but, well, multiple universes all existing at the same time.
Yeah, and actually that's fine. Like if this is the observable universe,
True.
maybe in this physical world, which is beyond it, there could be other universes. Maybe. Why not? Why limit God to one universe?
True.
You know, God is not so weak as to only be able to manage one universe.
Yeah. True.
So it's perfectly, from a Christian standpoint, a multiverse has no problem. We have no problem with the multiverse. We have no problem with a multitude of multiverses, you know? We're dealing with a God here that is not like some sky daddy.
True.
That is not what we're dealing with here.
Exactly.
When we're talking about God, we're talking about a being that is of incomprehensible power and majesty and holiness. He is not like us in the realm of which we're limited. Managing the physical world with its universes or multiverses, or the spiritual world with whatever is constituted that's like a daydream to God.
True.
You know, that's something that he can do as like that kind of operation for God is a afterthought to him. This is what we're worshiping. This is the kind of God that we worship. Okay? And this being loves each and every one of us so much that he sacrificed everything in order to restore his relationship with us. That we, as fallen creatures, willfully decided to break through our actions. So this is the kind of God that's so big that he doesn't even overlook us tiny, insignificant creatures.
Exactly.
We are big creatures to him because of how much he loves us.
I think we often limit God. We put him in a little box, and that can't contain him. The universe can't contain him.
Right.
You know, but we have to have something, and I think we want to control the situation
Yep.
more than letting God control it, because it's just one of those little things that we can do, we want to do.
Yeah.
So we bring him down to our level,
Yeah,
and,
yeah, we reduce God.
and it doesn't work, yeah.
We reduce God down to human terms,
Yeah.
so that we can understand it,
Yeah.
but he's so much greater, bigger, huge.
Yeah.
Yeah, and even with that, you know, that's amazing to think about it.
Yep.
You know, how much bigger God is
Yeah.
Yeah.
than what we can comprehend.
Oh yeah. This. Remember when we talk about God and we talk about Him being holy. Holiness is not limited to just a moral status. This is talking about just being the otherness of God. He is very much beyond us. He is further removed from us than like J.K. Rowling is to Harry Potter.
Yeah.
You know, like and this is why the Christians believe that we can't, by our own efforts, reach God.
Right.
He has to reach us because He's the only one with the power and the ability to do that. So like even managing all of this is like an afterthought to God. Thinking about each and every one of us, He has our full attention. John, you have God's full attention. Esther, you have God's full attention. And I have God's full attention. Each of our stories has God's full attention and His full love in bringing about good for us. All right. We've been going for an hour. I think that's a good place to stop. I'd like to thank everybody on Facebook, and thanks for joining us. If you're there, I don't know if you are. I can't see comments or anything, but please don't forget to check out Northeast Christian Apologetics for more apologetics-related content and theology-related content, and also Reasonable Faith in Norwich. We here at 340 New London Turnpike every first and third Thursday of every month. And hope to see you there. Really appreciate you guys checking in. All right. God bless. See you later.